Hi everyone, today we're going to be learning about distributive property. Actually, we're going to be reviewing distributive property, something that we have seen in the past with a whole bunch of properties that we reviewed. Equivalent expressions is just showing you how distributive property is equivalent to an expression written once it is evaluated or solved. So we're going to go ahead and begin here with our first problem. We have example number 1 here, and we're looking at 8 parentheses negative 9 plus 4. Now, we normally in the past we're used to solving parentheses first, order of operations, but we're going to go ahead and take it with distributive property a little bit different. Now, remember when we did distributive property in the past, we took the number outside the parentheses and we use arrows to help us understand that we would be taking that 8, that number in front, and we will be distributing it, which means multiplying it times everything inside the parentheses. So I'm going to do that 2 times. Why 2 times? Well, I have 2 terms. I have negative 9 and a positive 4. So when I go ahead and I multiply 8 times negative 9, and then I'm going to go ahead and take that answer, but I'm not going to solve it yet, and add it to that 8. Once again, I'm distributing times 4. So I'm going to go ahead and say 8 times negative 9, negative 72. And let's go back to a little bit about integers, right? Plus 32. Now, I have a negative number and I have a positive 32. Let's review a little bit. The rule was different signs we will be subtracting here, which means I'm going to go ahead and have a positive 40. And I'm going to go ahead and take the sign from the biggest number, the one that has the absolute value. So the absolute value of negative 72 is 72. And the absolute value of 32 obviously is positive 32, right? Now, 72 is greater and 72 has a negative sign. Therefore, my answer here is negative 40. So that was just a bit of a review. Going back into absolute value, we're taking the absolute value of the greatest number here, and which is 72. Therefore, we're going to keep this as a negative 40. The answer would be negative 40. Let's move on to example number 2. Example number 2, we have once again 2 expressions inside the parentheses where we have now encountered a variable. Same rule, we're going to take that number outside the parentheses, multiply it times everything inside the parentheses. So we have 4 times x. 4 times x is just 4x. And we have 4 times 7, and that is positive 28. And you're done. Now, you cannot do anything with this term. You cannot add it. You cannot subtract it. They are unlike. In order for you to be able to combine terms, you must have the same variable. So this 4 carries the variable x, but the 28 is a constant, does not carry any variables. Therefore, you must leave the answer as is. Moving on to our example number 3. I am going to go ahead and take 6 and multiply it times p. And 6 times p is 6p. And 6 once again times 5 is, and make sure you take your minus there, 30. Now, let's talk a little bit about that minus sign. Remember that I always told you to treat that minus sign as a negative sign. Whether you treat it as a minus sign or a negative sign, you're going to end up with the same answer regardless. So think about if you were to say, well, this is a negative 5, because the sign of a number is always in front of that number, right? In this case, we can also say if this was to be a -5, that means that I will be multiplying 6 times -5, which turns out that a negative times a positive becomes a negative. So my answer either way will be -30, assuming that I was treating this as a negative sign, which I'm going to show you another example on why you should, and I'm sure some of you already remember this from the past lessons that we did, but we're going to go ahead and go back and recap on that. And there's your final answer once again. Example 4. I'm going to go ahead and distribute -2 times x, -2x, -2, and notice this is where it comes back to you. -2 times -8. I'm treating my minus like a negative. That's going to give me a +16. And I'm done. But let's go back and talk about why did I treat that minus sign like a negative sign? Well, let's go back here one more step. Let's retrack. So let's assume I go ahead and I say, well, -2 times x is -2x, right? Clear. -2. So I'm going to go ahead and not treat this like a negative, but I'm going to treat it like a minus. I'm going to say, let me bring my minus. Now, let me go ahead and multiply -2 times a +8, right? Because I just took that minus and I brought it over here. So I'm going to go ahead and take this as a +8. -2 times a +8, negative times a positive is a -16. Now, to differentiate, I'm going to go ahead and add my parentheses here. And guess what happens here? You have minus minus, which means negative times negative. You're going to have to change this to positive. And that is the reason why I kind of save you guys that one extra step by telling you just treat your minus as a negative sign, because eventually you're going to end up switching it and it's going to work out. So that was another recap. Let's go ahead and move on. Once again, we're reviewing. Okay, so now this one has two terms that have variables. See, this is a -3x and this is a +7y. So same rule, we're not changing anything. We're going to go ahead and multiply +5 times -3x. That's -15x. Notice how I know, obviously, my integer rules. Very important. 5 times a +7y, that's a +35y. I cannot combine this term with that term. They're absolutely different terms. This one carries an x variable, where this one carries a y variable. Therefore, my answer remains the way it is. Final. Okay, last problem, fractions. And I'm going to go ahead and do 2 on these because I know a lot of you run away from fractions. So one step at a time. Once again, the rule says go ahead and take that number in front of the parentheses and multiply it times everything inside the parentheses. So we're going to take that 1/3. Let me go back here a minute. Sorry. Okay, 1/3 times x. So that's going to give me 1/3 x. Not a problem. But now we have 1/3 times -6. So I'm going to say, go ahead and bring that over because we know it's going to be a negative, but let's go ahead and recap here. If we're multiplying a fraction times a whole number, 6, in this case 6, there's my dot, 6. Whenever you have a whole number, you can put it over 1 to make it a fraction, since we're working with fractions now. 1 times 6, it's just going to give me obviously 6. And I know that some of you probably already know the answer here, but I'm just recapping for those of us that we need to go back and review a little bit of fractions. Then you're going to go ahead and multiply your denominators. So I did my numerators first, and I did my denominators. Now I have here what's called an improper fraction. The numerator is greater than the denominator. Therefore, I can actually divide 6 divided by 3, and that's going to give me 2. So my answer here would be 2. That's my final answer. Okay, now notice how this answer here was written with the parentheses here where you're differentiating that there's a plus, a -2. Same thing. These are both what's called equivalent expression. This expression here, this distributive property is equivalent to that, and so is this one. They're all equivalent expressions. Now, we're going to go ahead and do our last problem for today. Last problem for today. One more fraction and we are done. So here it is, 1/4 times x, and you can go ahead and pause the video, take notes, work it out before you get to my answer to make sure that you understand what you're doing. So you have 1/4 x and you have 1/4, and notice I'm going to bring my minus again because this is a positive times a negative. So that's going to be a negative here anyways. And I'm going to go ahead and do a little bit of fractions here to recap. 1/4 times 16, which is obviously a whole number. I'm going to put it over 1. I'm going to multiply my numerators, my denominator, and 16 divided by 4 is equal to 4. And that's where my 4 came from, if you can read it. And there it is. So yes, we have reviewed distributive property today. I hope that you find this video helpful, and I hope you have a wonderful day today. Bye now.